suppose that little things behaved very differently than anything that was big. Anything that you're familiar with. Because you see, as the animal evolves and so on, and his brain evolves, it gets used to handling, and the brain is designed for ordinary circumstances. But if the gut particles and the deep inner workings were by some other rules and some other character, they behaved differently, they were very different than anything on a large scale, then there would be some kind of difficulty in understanding and imagining reality. And that difficulty we are in. The behavior of things on a small scale is so fantastic. It's so wonderfully different, so marvelously different than anything that behaves on a large scale. You say electrons act like waves. No, they don't exactly. They act like particles. No, they don't exactly. They act like a kind of a fog around the nucleus. No, they don't exactly. And if you would like to get a clear, sharp picture of an atom so that you can tell exactly how it's going to behave correctly, have a good image, in other words, a really good image of reality, I don't know how to do it. Because that image has to be mathematical. We have a mathematical expression, strange as mathematics, I don't understand how it is, but we can write mathematical expressions and calculate what the thing is going to do without actually being able to picture it. It would be something like a computer that you put certain numbers in and you have the formula for at what time the car will arrive at different destinations, and the thing does the arithmetic to figure out what time the car arrives at the different destinations, but cannot picture the car. It's just doing the arithmetic. So we know how to do the arithmetic, but we cannot picture the car. No, it's not 100% because for certain situations, a certain kind of approximate picture works, that is simply a fog around the nucleus that when you squeeze it, it repels you, is very good for understanding the stiffness of material. That it's a wave which does this and that is very good for some other phenomenon. All right? So when you're working with certain particular aspects of the behavior of atoms, for instance, when I was talking about temperature and so forth, that they're just little balls is good enough, and it gives a very nice picture of temperature. But if you ask more specific questions, and you get down to questions like, how is it that when you cool helium down, even to absolute zero, where there's not supposed to be any motion, it's a perfect fluid that hasn't any viscosity, has no resistance, flows perfectly, and isn't freezing? Well, if you want to get a picture of atoms that has all of that in it, I can't do it, you see. But I can explain why the helium behaves as it does by taking my equations and showing that consequences of them is that the helium will behave as it is observed to behave. So we know we have the theory right, but we haven't got the pictures that will go with the theory. And is that because we're limited and haven't caught on to the right pictures? Or is that because there aren't any right pictures for people who have to make pictures out of things that are familiar to them? Well, let's suppose it's the last one, that there's no right pictures in terms of things that are familiar to them. Is it possible then to develop a familiarity with those things that are not familiar on hand by study, by learning about the properties of atoms and quantum mechanics, by practicing with the equations until it becomes a kind of second nature, just like it's second nature to know that if two balls came toward each other, they'd smash into bits. You don't say the two balls, when they come toward each other, turn blue. You know what they do. So the question is whether you could get to know what things do without better than we do today. You know, as the generations develop, will they invent ways of teaching and so that the new people will learn tricky ways of looking at things and be so trained, so well trained, that they won't have our troubles with the atom picturing. There's still a school of thought that cannot believe that the atomic behavior is so different than large-scale behavior. I think that's a deep prejudice. It's a prejudice from being so used to large-scale behavior. And they're always seeking to waiting for the day that we discover that underneath the quantum mechanics, there's some mundane, ordinary balls hitting or particles moving and so on. I think they're going to be defeated. I think nature's imagination is so much greater than man's, she's never going to let us relax.